So welcome everyone. We have a full room already. We can start with the agenda for the day and why we have community calls and how you can participate in the community call. So, Yuti, do you want to share the screen? First of all, this is, if you haven't met him, I think most of you have, this is Guilty Gyoza or Thomas. And yeah, he's a big person in the ecosystem and one of the key people doing the work. We also have some members of the team in the chat. So if you have any questions during the call, we're going to be replying to them at the end. And yes, you can ask all sorts of questions. We have somebody for that in the call. Okay, can you share your screen?
Yep.
So if you're new here, you can always say you are, like, you can drop a hi in the chat and tell us where you're talking from. We are very happy to know, to hear how topology is spreading around the world. So, okay. So first of all, community call. The community calls are meant for you to join and see what progress we are doing. What is the progress we are doing regarding the development of the topology protocol? You can always bring questions. So we have some documentation, some material you can read in between the calls. And we have some other calls for you to participate in. And you are welcome to join and bring questions, bring things to share. So maybe you have a vision that the idea of an app you want to build, and we are here to support you. Maybe you want to contribute. So our protocol is open source, and you can be part of building this with us, right? So first, I want to tell you what we're going to do today. So can you move to the next slide? Yeah. Right. So first of all, some announcements, quick announcements, and then an introduction to what topology is. So if you are new here, what you should remember after the call. And if you are not new here, we have, following that, what is topology protocol, we have protocol updates, the development side. And then we're going to check what documentation we have for you. And this documentation is already open for you to check and visit and give feedback. So at the end, we have the AMA, the Ask Me Anything session. So you can write down questions during the call, drop them in the chat, and we're going to get to them at the end. Next slide. All right, announcements. So last couple weeks already, wow, it's moving fast, we were in Bangkok. So here's what happened in Bangkok while we were there. And we were so happy to meet the community. And we usually talk during these community calls, we usually talk on online events or via messages, but being in person is such a good experience, and we really loved talking to each of you. So we hosted a dinner for some people to eat something good together. And we also had some presentations. So Guilty was presenting about topology in several places, Komorebi's Hacker House. We were at the Autonomous Anonymous event, and it was very fun to be there. So if you are one of the people who were there and met us there, it was very fun to meet you. And if you were not, we are looking forward to meeting you in the next event. So it was our pleasure. And then we also had, this is ongoing, and let us know if you are in Zoo Thailand right now. We had a presentation about what topology is during Zoo Thailand. Zoo Thailand is an event that is ongoing. It lasts for 4 weeks. So if you are there or if you know someone who's there, you can check if they are building on top of what we are doing, on top of topology protocol. So you can ask questions, you can check if they want to build something together. So if you know someone there, you can always say that you have someone, you know someone in common, right? And yes, so this is a very fun experiment. And if you want to connect with us and stay connected, ask questions. So we have all sorts of things going on in our Telegram. We have this very, very cute mascot. Oak is the engineer of the team, is the head engineer of the team, and he got this Utah, perfect baby Utah, and yeah, so this is one thing that happens in the chat. We are also engaging with every question that you may have. So maybe a question comes up after, and there are no silly questions. You can ask anything you want. You can propose something for in the chat. We want to make this open as much as possible for you to participate and build this Telegram chat with us. So you can feel free to ask us for something, ask questions, and invite people. Oh, he has an Instagram. Okay. Oh, Yuta has Instagram. All right. I bet he has more followers than I do. That sounds nice. Okay. So, So moving on. What is topology protocol? Right. So if you have just joined us, or if you are wandering around, and what is topology after all? So we have an introduction to topology call that happens monthly, where we go in deep dive about what topology is. And that call happens tomorrow again. So tomorrow at the same time of this community call in this link. So it's very easy for you. Just come here again tomorrow and you can participate and learn everything about topology. So how we started, what we are doing right now, and our plans for the future. But in between that, I want to share that topology, what is topology, right? We are an open protocol and building to enable real-time sovereign applications. And if you want to know more, really come tomorrow, right? And what it means is that the real magic happens through real-time interactions, which allow us to connect in a meaningful way, despite any physical distances that we may have. And right now we are doing exactly that. We are connecting through distance and in a meaningful way. So what is the difference? We are currently connected and live, and our community's potential is only limited by relying on centralized servers, right? So to build digital spaces with true independence, we need a new technology. And the question now is, how can we create this magic of presence in digital spaces without depending on any single entity or the goodwill of people or interests? So moving on, yes.
Now, the question of how can we create the magic of presence without relying on centralized servers? Well, the world computer, right? That's a great answer, right? Ethereum pioneers the idea of the world computer, which is also an infinite garden. And what that means is it is a diverse ecosystem with diverse individuals and organizations that are building together and evolving together in a very organic manner. That's the vision of the world computer as an infinite garden. Now, it is also running without a centralized servers, a reliance on centralized servers, and it's censorship resistance, and the entire computer belongs to the community. That is a great answer to the question. Now, we are fully aligned with the vision, and we are taking it further. So there is a new protocol design space that is focusing on real-time programs running in a distributed manner. And this design space actually precisely complements the strength of Ethereum or any blockchain. And so from this complementary position, we are building a protocol, and this is not a crypto protocol. This is a open internet protocol. And we're calling this protocol DRP, or Distributed Real-Time Program. For those of you who have been attending our community calls in the past, the old name for the protocol is Topology Protocol. Now we're calling it DRP, Distributed Real-Time Program, or DERP. That's how you would say it. We're creating DERP, and it is an open internet protocol that we're dedicated to driving real-time decentralized applications to have it help add value to every blockchain and to eventually drive DRP into the internet protocol stack. And in this community call, we will be focusing on sharing the development updates on the protocol or the DRP. So if you have any questions, in the meantime, drop it in the chat and we'll answer the questions at the end. Now we move on to updates on DRP development. So there are a couple updates since the last community call. First, we are building finality, and in the process of building finality, we are building access control mechanism to the protocol. Now, what that means on a high level is finality allows us to finalize parts of history of a program on DRP. Finalizing means that there are certain things that happen in the past of the DRP, and they have a notion of being agreed upon by actors in a DRP so that they are final. And finalizing these allows us to send these information to other places, and they have a certain weight and agreement that comes behind them. For example, you can have a DRP settles on a blockchain of your choice, and that would typically be done preferably if you're settling finalized information from DRP to the blockchain. And in the process of implementing finality into the DERP protocol, we are also making access control, which means for the program to decide who can and cannot have access to the program, because only with that can we decide who has the right and say to participate in finality, right? Because finality represents a notion of agreement, but agreement by whom? We need to have a notion of a group of people or actors in the program that have the rights to participate in the agreement. And in order to do that, we're implementing the access control mechanism right now. The second point is benchmark. It's also something that we have made in the past weeks, and we're actively enhancing it. So benchmark allows us to quantitatively argue every new PR and enhancements that we're making and then adding to the code base. So it is currently measuring the CPU time and the memory usage of different kinds of operations that you can perform on DRP. And we're looking to have a better suite of benchmark tests and also better panel and visualizations and tools for tracking those numbers and statistics. The next point is infra. So we are also making it and enhancing our infrastructure. Now, there are many parts of this, but one important part of the infrastructure is that we are running a couple dozens of DRP nodes on our own machine. By our own machine, we mean that we are renting certain machines from the cloud and we're running the DRP nodes and maintaining them there. And the reason why we want to do that is really manifold, but one reason is we can maintain a healthy network topology and connectivity, and those DERP nodes can serve as the basis for many other things, including something called the DHT. Now, the DHT is basically a fancy way to say you have a table that is stored in a distributed manner. And this table sort of records who is in which DRP program, kind of like a phone book, but maintained in a distributed manner instead of sitting in a single machine. And you would ask, why is DHT important? Because with this phone book, we can greatly improve connectivity. So for example, for anyone new to the network that wants to join a DRP program, that person needs to know at least someone that are already in that program, and they can connect to them as a leeway to other people currently sitting in the program. So connectivity issue is a central issue in all P2P systems. And long story short, we're creating infrastructure to as a way to enhance that. And the final point is documentation. We have completed the end-to-end first run of our documentation for the protocol. And the documentation doesn't go into any technical details of the protocol. The purpose of the documentation is to give you the minimal set of core ideas that you need to grasp before you can make a DRP program from 0 to 1 on your own. And the documentation also has 2 tutorials covering how to build applications from scratch with DRP. And with that, we can move on to documentation. So you can find the doc under this URL, docs.topology.gg. And let me see. I'm going to share it now. Let me see if I can. I have the link here. Yes. So I think we can do this, and just make a new tab and run the docs here. So if you visit this URL, you will see the documentation. And the first thing you will notice is it currently still reads topology documentation. We're in the process of restructuring this documentation to reflect that from now on, we're calling the protocol DRP. If you go into the Get Started section, from 1 to 5, these are the 5 pages that you would go through to grasp all you need to understand to build with the protocol. So first of all, it gives you a very high-level introduction of the protocol, its motivation, why we're making it. It then covers concurrency, which is the idea that things can happen at the same time in a DRP, and we do not force order them. Or in blockchain speak, everything that happens in the history of a blockchain sits on a single line, right? So everything is strictly before something else or after something else. But in a DRP, we are saying no, we embrace the idea that things could have happened concurrently at the same time, and we let them be. They happen at the same time. That is the secret of DRP able to run very fast in real time. And that brings us to Hashgraph. And Hashgraph is the data structure that we are maintaining the history of a DRP, or you can call it the causal log of a program with DRP. And this is the page that gives you just a high-level idea and structure of a hash graph, what you can do with it. And then moving on to the key idea of conflict. Now you can put in the chat, maybe there is a better word that we can use to call this idea conflict. But conflict really is the traditionally in the academia and also in this very rich body of distributed system research, the precise word that this is called is called a conflict. And the conflict is called things that happen at the same time, but they the order at which you execute them would give you different results. Okay, so just to walk it through very quickly here, we have add 7 and multiply by 3, and you can roughly see them as happen concurrently, right? So they both happen after this symbol. We don't care about this symbol, but all we need to know is add 7 and multiply by 3. In the history of this program, they happen at the same time. And we all know that addition and multiplication, they do not commute, which is just a mathematical way of saying that if you add 7, then multiply by 3, versus you multiply by 3 first, then add 7, you would arrive at different answers, right? And we're calling this a conflict. And to deal with conflict, we need conflict resolution. So it's called resolving conflicts. So if you're making programs with DRP, as part of your program, you need to specify what kinds of conflicts can arise and how are you going to solve it with your program. And when you do this correctly, any conflict that arises will get resolved instantly according to how you're specifying them in your program. So this is one way to say that there's no conflict, strictly speaking, in these programs because whenever they arise, they get resolved instantly. Finally, there is this concept of an object. We're renaming this to a DRP program. But what this means is this basically corresponds to a small contract on any small contract platform, say Ethereum. So you would think on Ethereum, I would develop a small contract and I would deploy it. Now coming to DRP, you would say, I'm going to create a program with DRP and the program will run with DRP, the protocol underlying it and enabling it. And this page basically walks you through the key components of a program that is created with DRP. The one big thing that you want to pay special attention to is this function, resolve conflicts. Is as you're writing these programs with DRP, as we know, we are embracing the idea that things can happen at the same time. Right? That is the secret of DRP programs running in real time. You need to think about conflicts and you need to resolve them in your program. So this function is a very important function for you to carefully implement so that your program can run in real time and be problem-free. And these are all the key concepts that you need to understand to start building with DRP. And here are 2 tutorials walking you through making an application from scratch. One is a chat application, and the other is a grid application. Now, the chat application is straightforward. It's a chat room. Whereas the grid application is this basic demo that we previously showed on Twitter. This is a demo where you have a 2D grid space, and every user is represented as a circle. And every user connected to the same grid space will see each other, and you can move in real time, and everyone else will see you moving in real time. Right? This is really, really a simple and basic demo, but I think it's quite obvious that this is the foundation for more interesting and more complex real-time either gaming applications or social applications and so on. So we hope that these tutorials make you more confident in making applications with the protocol, and it inspires you with imaginations. Now, coming back to the slide, this is basically the last slide. We are approaching the end of the community call today. So if you're interested in anything that we said, if you're inspired and aligned with our mission to build DRP, the Open Internet Protocol, join our Telegram group chat where we vibe and discuss together. If you want to read our code base, it's entirely open sourced under the Topology Foundation GitHub repo. It's an organization. And finally, we're also on OniDust. So we have a long list of open issues that we're welcoming contributions to. And we are welcoming contributions and collaborators on the OniDust platform. So join us and ask us any questions.
For the walkthrough over updates and documentation. And I've been following the chat. We haven't received questions. We've received a meme of derp. but no questions so far. If you have any, you can use this moment. You can also share an idea and check if it's receive feedback right now, check if it's valid. And we are, yeah, we are here for it. So let us know. And
I'm going to stop streaming so I can look at the chat room now. Wow, we have people from all over the world joining the call here.
so we have Poland, Germany, China. Yeah, that's cool. And first question, what's the motivation behind changing the protocol name to DERP?
Well, there's really just one single motivation, which is to call the protocol what it is, to be as simple and straightforward as it is, and to be generic and upfront about what it is. So I think topology protocol is the old name that we used to use. Now the thing is, our team is also a topology team, and topology protocol, it doesn't really communicate much about what the protocol is enabling. People may confuse it with topology in mathematics, and it is a great name, but it doesn't serve the purpose of clear communication. And we think that DRP, distributed real-time program, it basically just tells you what the protocol is and what it enables, and we think it's a good name in that way.
Okay, so could DERP be used in programs developed based on MUD, TypeScript and Solidity?
Right. So this is pretty tricky question. Now my imagination is really growing now. I would say yes and no. Yes, in the sense that I welcome and invite you to create a MUD framework for DERP from DERP's perspective. Now the thing is, MUD is created with a very particular focus, which is to enable uh, scalable and complex applications on Ethereum on the EVM system, right? So a lot of its design choice is following this core goal is to have a framework for state management and updates management so that you can create more complex applications on EVM without writing a lot of low-level infrastructure. So coming to DRP, first of all, you don't necessarily need Solidity because right now with our protocol implementation, you can implement your program in JavaScript or TypeScript. You don't need to stick to a particular VM that is particular to any blockchain. Another thing is you can your front end will still be a front end if you want to run it in the browser. So the front end part of your program application doesn't change. It changes in the sense that it has to now interface with a DRP program. It's not interfacing with a Solidity smart contracts. But I think really the opportunity here for two opportunities is one, with DRP, there exists a ECS framework or multiple that allows making more complex DRP programs. I think that intuitively makes a lot of sense, and that is a big opportunity. And I think another opportunity is probably thinking from your perspective. You're probably thinking, I have an applications made with mud. How can I migrate or redevelop this application with derp and minimize the change and the migration cost? Well, your front end is going to change quite minimally in a sense that your rendering doesn't change and your input captures. I imagine you are making a game, so you would have logic that are handling capturing the player inputs. Those parts doesn't change. What you're only changing is instead of thinking you're interacting with a smart contract, you're just going to interact with a DRP program. And a DRP program is not going to be likely not going to be written in Solidity. You will write it in JavaScript or TypeScript. Now, in the future, we want to have WASM as the official runtime for the derp nodes that we're making. And having WASM as the runtime means that you can build your derp program in any programming language that compiles to WASM. So that really opens up the sort of the programming language space for programs that can run with the protocol. There's also no indexing in the sense that for people that know Mud, they also handle indexing, which means that they're taking care of capturing the things that are happening on chain in your smart contract, and they're organizing these happenings in a nice, neat database for you to query on the front end. Now, we don't have to do that with derp because we don't index. Instead, every user running a derp application on their browser or on their machine is going to have a copy of the entire application. Whatever changes they make to that copy, it becomes effective immediately, and they can see the result immediately, which means it's very responsive and alive. And also, any change that other people in the same program are making on other places, they are magically synchronized to your copy. I mean, as a player or as a user, so that you're seeing those changes as fast as the internet allows, which is your Wi-Fi speed or your bandwidth, and you're also seeing that reflected in your applications as fast as possible. So this really simplifies the complexity of the entire netcode compared to if you're making an on-chain applications. That's sometimes what we call when we say we're focusing on maximizing the developer experience of derp, and coming from the underlying technology, which some of you may know, is coming from the CRDT technology. One of the main selling points of CRDT, the underlying technology, is that it reduces the complexity of netcode by 10x easily. So you can make network applications that are way less complex than otherwise. And we're taking that further, making a protocol and really focusing on maximizing the developer experience. Okay, reading another question from the chat. Looking forward to see the future of derp. We as well. And also wondering what are the benchmark metrics that we are using. So right now, let me see if I can call upon the benchmark. If this is not a great idea, anyone shout in the chat and stop me. Otherwise, I will call upon the benchmark on my browser now. Hmm. Okay. So I'm going to share my screen, which will show you the dashboard of our current benchmark results. Okay, so we're making the benchmark system on benchmark.js, and this is currently reflecting the latest commit that we're making to main on TS Topology, which is the TypeScript implementation of the protocol. And it is currently tracking two things. One is, and let me zoom in. One is how much time does it take to create a hash graph with 1,000 vertices in it? And you can see it currently sits at 250 operations per second, which means that if one operation is creating a hash graph with 1,000 vertices, you can do this 250 times per second, if that makes sense. And the second thing that we're tracking in a benchmark is basically the merge function. So you can have CROs, you can have programs with the protocol. CRO is the old name that we used to call these programs. And they will have a lot of vertices, right, in their history. And the thing is, when they synchronize, they need to merge so that they both know what each other has in their history. That's a merge operation. And merging two graphs can be compute intensive, so we're having a task in the benchmark to track that. And you can see we're tracking how much time does it take to create two such hash graphs and merge them together. Currently, we can do 1 op per second. That means that every second you can create two such big hash graphs and complete a merge function for them. Does that make sense? Or if I'm saying anything wrong, point me out in the chat.
Anderson was typing something.
I'm gonna stop streaming that now.
Okay. Yeah, I think we are all uploading. Yeah.
Thanks for sharing. Yeah, I was going to just quickly say hi to a few people in the audience that I met in person in Bangkok. Jimmy, we met in Bangkok, and we had a dinner talking about stuff from the status quo of the ecosystem. Where does the hope lies, and where are we going as an industry, and so on. That was a fun convo. CK, we have been talking a lot at the Komorebi Hacker House, and we have been talking about making games and what Mud is doing and what we are offering differently with the protocol here. We know that we're making a protocol that is very different from blockchains, and we're doing the best job we can to communicate the value add and the work. Hatsume, we also met. We had a dinner together. It was great having you there. Anderson, we also had you at a dinner. It was great having you there. And some of the other people, I think DDY, we talked a lot at the Starknet Hacker House about Dark Forest. So for the audience here, DDY is sustaining the life of Dark Forest after the official team making Dark Forest and sort of moving on to running the Xerox Park organization. And DDY is this passionate team in China that is sustaining and still growing the Dark Forest brand and running the games. Leo, we also met at the Starknet Hacker House. It was great meeting you in person for the first time, and we look forward to having more presentations together.
Okay, awesome. And if we haven't met in person, we're gonna meet eventually in another event, I'm sure. And until then, we meet in these community calls. If you have any final questions, I think now is the time. And yeah, so otherwise we are approaching the end of the call. So this is your last chance. Oh.
My laptop just died. Sorry, so
Okay.
I'm not on now. And the magical background disappeared. I'm disappointed.
It's okay. All right, so I think that's it. I think we can wrap up the call. Thank you everyone who joined us today. It was great talking, and hope you have been inspired by what we discussed. Don't forget that tomorrow at the same time we have Introduction to Topology call, so you can learn. And this is a good call if you are not a good call to join if you are not super technical as well. So you can also learn more about the vision and all and get more context on why we are doing what we are doing.
Thank you, everyone. See you tomorrow. Bye. Take care, GMGN.
Bye.